Okay, Unit 18, problem 25, I do believe. Yes, there it is. So this is one of the trickier ones in the unit. So we'll just get started. First, we need the balanced reaction. So we have KOH plus HI. So there's your base and there's your acid. We're just going to do H2O, so HOH plus Ki. So now we balance it. Oh, it already is 1, 1, 1, 1, 1. That makes life a little bit easier for us. So now we're given some KOH is going to be added to 1 liter of this. Well, that's a molarity, so let's find our moles. Molarity equals moles per liter. We fill in, and we get 0.30 equals x over 1. Multiply this there, clear the bottom of that, and it's 0.30 moles of HI. Okay, now what are we adding to that? 1.1 moles of KOH. So since it's 1 to 1, we could do the limiting reactant problems. We could do the limiting reactant numbers, and we could go through the steps if we wish. But it's kind of easy in our head because if it's 1 to 1 and you have 0.1 and you have 0.3 moles, which one's going to run out first? Well, it's this one. Now, if these ratios were different, we'd have to worry about that and do our limiting reactant stuff. But this is 0.1, 0.3, and it's 1 to 1, so the smaller one will be the limiting reactant in this case. It's not always the smaller one because the ratio matters. But since it's 1 to 1, yes, it is the smaller one. So what we're going to do is we're going to take the 0.1 moles, and that's our limiting reactant, moles of KOH, and we're going to see how much is left. So we know how much are we going to use of the HI, okay? Because basically this is wanting to know how much is left over, and then we need to turn it into a concentration. So it's 1 to 1, Mr. Endershot, you already said that, so that makes it easy. 1 KOH for 1 HI. So what does that give us? We use 0.1 moles of HI is used to consume 0.1 moles of the KOH that was added. Okay, so what is left? So what is the excess amount? Well, what did we start it with? We started with 0.3 moles of HI. We used 0.1 moles. 0.1 moles. So how much is left? 0.2 moles of HI, that's important, left. Well, we need the concentration of this.
You want more cheese?
Well, if you recall, the concentration in molarity, so we need to turn this to molarity, so 0.2 moles of HI, and that is 0.2 moles of H's and 0.2 moles of I's. Okay, perfect, because we want the concentration of the H3O, which I said in a previous video, hydronium ions we will consider equal to H plus ions for us. So if we have 0.2 moles of H plus ions, we just need to get the molarity. So if we take 0.2 and divide it by our volume, which is 1 liter, we end up with 0.2 molarity. And that is our solution. That is our answer for that one. Okay, what about part 2? Okay, part 2 is a little trickier. The same idea, but in this case, since it's still the same reaction right here, let's get something different color. We have this much added. Well, which is now the limiting reactant? Is it 0.3 moles? Because we start with this again. Or is it this? Which one's the limiting reactant? Because the limiting reactant's what's going to be consumed, so then we need to find out how much of the other one we used. It's this one. This is the limiting reactant this time, and this would be the excess reactant. Okay, well, okay, we need to figure out how much we used of it, right? So 0.3 moles, and it's a 1 to 1 ratio again, so 0.3 moles of HI So how much do we need? 0.3 moles of KOH. Boom, those react, and so this is gone and this is gone. Well, how much is left over? Okay, we started with 0.94 moles of KOH. We then used up 0.3 moles to consume the 0.3 moles of HI. So what we have left is 0.64 moles. Now many of you are already saying, okay, 0.64 is the answer. Like it was 0.2 there, and Mr. Hendershot did a lot of stuff I didn't even pay attention to, and so I just put 0.2 in, no need to think anymore. Wrong, right? The numbers were nice, and another thing about this is, look at this. They want this much the same that they wanted here, right? But before we had 0.2 moles of HI, right? Well, that means 0.2 moles of H plus ions, which is, so that equated nicely. But here we have 0.6 moles of KOH. Well, that's the problem. They still want the concentration of H plus ions. Well, how do you do that? Well, there's two ways. One, you could use the formula and turn this for finding this concentration, doing a negative log of the ion after you divide by 1. A negative log of this will give you POH. Do 14 minus POH, and you get pH, and then do your formula pH and get the H plus ion concentrations. That's really like 2 more steps. It's really not that bad. However, I got a quicker way. Like, ooh, sign me up, one more. So if you get it back to the equation sheets, video 2 maybe, instructional video 2 or video 3, I can't remember, in the original 5 instructional videos for this unit, there was the H plus ion concentration times the OH minus concentration, and that gives us 10 to the negative 14th. So we know this, well this, hold on, we got to divide by 1. So if we divide by 1 liter, it's 0.64 molarity of the OH ions, because it's KOH and it's 1 to 1, right? 1 K plus and 1 OH minus for every one of these for every one of this. Okay, so this is our concentration, 0.64 molarity OH. You fill this into here. So it's H plus ion concentration. If you want to call that X, call it X, whatever. And this is 0.64 equals 10 to the negative 14th. So basically take 10 to the negative 14th and divide by that. And that's when I get this. I think they want you to round to 2 significant digits. So there you go. And that's the answer. So